Welcome. We're on problem 4-104. Graph the solutions to each of the following inequalities on a different set of axes. Label each graph with the inequality as given and with its y equals form. Choose a test point and show that it gives the same result in both forms of your inequality. So letter A, we have 3x minus 3 is less than y. For most of us, we are a little bit more comfortable with graphing linear functions when we have our y out in front. So I'm going to go ahead and rewrite this as y is greater than 3x minus 3. Remember, the alligator eats the bigger meal. I don't know, I heard that in first or second grade and it's stuck with me ever since. Okay, so I want the values of y that are greater than these values. Now, we shouldn't have too many problems graphing this here. We have our slope is going to be 3 over 1, so we're going to rise 3, run 1, and we're going to start at the y-intercept, which is going to be the point 0, negative 3. Now, we already know that this is going to be a dashed line because there is no equal sign. So let's start here by putting our points on here. So here's our y-intercept. We're going to rise 3, run 1. Rise 1, 2, 3, run 1. Because I can't use a straight edge on here to draw it, and it's too hard to get to the tools, I'm just going to plot all the points all the way across. And now I'm going to just draw in my dashed part in between. So we know that because it's dashed, none of these points on this line are actually going to make the inequality true. They are not solutions. On this coordinate plane, the values that we need to have that would make it true are going to be all the y's, or all the points that have y's that are greater than this line. So if I picked any point here, let's say right here, and I'm looking for a y value that is more than this, I move up and I end up being above the line. So we should be shading over here. So let's take it here. Let's use our crayon. Crayons are more fun. So this side is the side that we say is going to be our solutions to this inequality. I'm just trying to be a little careful here. It's kind of hard to draw on here sometimes, but all of these points here, everything on this side is a solution to this inequality. I'm going to check my answer right now by picking a point from over here and plugging it in to make sure it's a true statement. My favorite point to plug in anytime I can is the point 0, 0. So 0, 0 falls on this side. We're going to plug it in right here. Let's check it. So our check, we're going to use the point 0, 0. So I'm going to plug in 0 for y. 0 is less than 3 times 0 minus 3. That ends up being negative 3. And 0 is greater than negative 3, so we know we are right. Let's move on to B. Oh, I'm sorry. We're supposed to label these. Well, here you go. You have y is greater than 3x minus 3, and 3x minus 3 is less than y. There's your labels for that graph. B, 3 is greater than y. I'm going to rewrite it first, just like I did on the last one. I'm going to rewrite it as y is less than 3. For this one, we know our slope is going to equal 0, and our y-intercept is going to be the point 0, 3. We should just know that by now. Okay, this is algebra 2. We should know that the graph of y is equal to something, or y is less than or greater than something, and we don't have any x values. It's always going to be a horizontal line. So we've got 1, 2, 3. Boom, there's our y-intercept, representing all the points that have y values that are positive 3, which extend forever this direction to the right and this direction to the left. Now, what points on the coordinate plane have outputs or y values that are less than 3? Well, as you go up, your y's increase. As you go down, your y's decrease. We want to be less than 3, so we're looking to be down here. So we can shade this graph underneath it. Let's get out another one. Ooh, let's do yellow. So we're going to shade right underneath this line. Make sure you try to keep it on this line. I know coloring inside the lines can be difficult for some of us. Actually, it's a little bit hard for me right now. There we go. So look, that's pretty. I like it. Let's check it. Let's use the 0.00 again because it falls in this one. So here's our check. We're going to check it using the 0.00. Well, our equation is y is less than 0, so we're only going to put in the 0 for y. So 0 is less than 3, which is true. We know we are correct. Hopefully you're getting the idea of what we're trying to do here. So this is the graph of 3 is greater than y, or y is less than 3. Let's do this one. Let's get y by itself here. I'm going to go ahead here and subtract 3x from each side. I have the opposite of 2y is less than or equal to negative 3x plus 6. Now let's get y by itself. This is the part where the errors occur, right here. We have to divide by a negative 2. I'm going to divide everything by a negative 2. And when you divide both sides of an inequality by a negative, or you multiply both sides of an inequality by a negative, remember you have to flip this inequality symbol. So this should become greater than or equal to. So y is greater than or equal to 3 halves x minus 3. Let's go ahead here and plot our y-intercept down 1, 2, 3. And we're going to do rise 3, but run 2 this time. Rise 1, 2, 3, run 1, 2. Or down 1, 2, 3, back 1, 2. Down 1, 2, 3, back 1, 2. It's got the positive slope we're looking for. Let's graph the line. So it's going to be this line here. The reason we've made it solid is because it contains an equal sign here. Now we're looking for all the values of y that are greater than the values of y on our line. Well, if we put our pencil on our line and we move up, our outputs increase, and this is the side we should be on. So let's take it here and let's shade this side. Let's use a color we haven't used. Actually, I'm going to shade along the line here so I can just go back and forth like this. Ooh, that's pretty. Once again, your check. Let's use the 0.00 because it exists in there. So if I said 3 times 0 minus 2 times 0 is less than or equal to 6. 0 minus 0 is 0, and that's less than or equal to 6. We know we're right. Letter D. X squared minus y is less than or equal to 9. Last one for this problem. So in order to do this, I'm going to show you a different way on this one. Last time, on part C, we subtracted the 3x, and we had to get rid of the negative 2. So when we did that, we had to flip our inequality. For this one, let's do it a little differently. Let's take it and let's go ahead and, instead of subtracting the x squared and then dividing by a negative, let's just go ahead and add y. And you'll see when we do that, we're going to have x squared is less than or equal to y plus 9. And then we have to get y by itself still, so we'll subtract the 9 from each side, and we're going to get x squared minus 9 is less than or equal to y. And if we rewrite that as y is greater than or equal to x squared minus 9, now we can look at this as graphing from a standpoint that we're more comfortable with. I know here that my A is 1, my H would be 0, and I have -9 as my K, which means that that's going to be our y-intercept. We're going to go down 1, 2, 3, 4, 5, 6, 7, 8. I think this is 9. I hope it is. We have our standard parabola shape, so over 1, up 1. Over 2, up 1, 2, 3, 4. Over 3, 1, 2, 3, up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. We could go over 4 and up and so on. You see what I'm saying there? So we're just sketching it here, so I'm going to use my axis of symmetry, which ends up being my y-axis, just to plot my other points. And this always ends up bad for me, so bear with me as I draw my parabola on this program. All right, let's get the second side. This one's usually the tougher one for me. Oh, shoot, I missed. Hold on, let's undo that. I have too much pride. All right. So we remember 1, 2, 1, 2. All right, so let's see. Maybe if I just kind of draw it in from up here. Oh, yeah, there it is. Holla! Woo woo! There we go. And let's just pretend. All right, you know, it should be symmetrical. It's a little off there, but everybody is a little bit from time to time. Now, we're looking for all the y values that are greater than or equal to the output values of this. These are all the output values of x squared minus 9 there. So when we're looking for the y values that are more than that, we're going to look above it. So our shading should end up occurring right inside, because if you think about what's above this, it's this area inside of here. So we should be shading in this region in here. Now remember, we also have our solid line because it was equals, just like in the problem before, and then the first two we didn't have the equals, so they were both dashed. Well, we can check this last one here by using that same point. Just so happens that it is a solution to all of these. If we take it and plug it in, I'm going to do it down here because I've run out of room. 0 squared minus 0 is less than or equal to 9. Well, that's pretty easy. We know that 0 is less than or equal to 9. We know it's true. We know we've done this correctly. And finally, we've made it all the way through. This is problem 4-104. This is Mr. Boyd. If you have questions, make sure you ask your teacher, ask me, ask a friend. Okay, but it's important that you remember how to do these. Thanks for listening. Good luck.